Hello students, welcome to the course Programming on ARM Cortex M3 or M4 processor. Before we start, let's see overview of the course. So this course covers equal importance to theory and lab session. Let's see what will you learn at the end of this course. So the first topic is about processor architecture. So you will learn about internal processor architecture, operations, mode of the processor, access level of the processor, and switching processor mode and bus architecture. And next topic is about programming model. So here you learn about internal register organization, special purpose registers, stack operations, and many. Also, you will learn about how to use KIMS Core API. So KIMS means Cortex Microcontroller Software Interface Standard API. It is used to access core processor register. So next topic is about memory architecture. So you will be able to understand the memory model of the processor, different memory interfaces and bus access, and also you understand how to use bit addressable memory region. And next topic is about interrupt and exception handling. So it covers about handling system exceptions and external interrupt. And fifth topic is about programming and debugging using Kale Microvision 5 MDK. So here I will show you how to install, configure the software packs and creating a project using Kale Microvision for all your embedded software development. And sixth topic is about debugging using logic analyzer. So this is a very important tool to debug the signals, protocols and interrupt, etc. So in this course, you will learn how to use this USB logic analyzer for your software debugging, and we will quote a lot of examples to understand things better. So in this lecture, we are going to understand about the differences between the processor core, processor and microcontroller. So before we start, let me explain the features of ARM Cortex M3 or M4 processor. So the Cortex M3 and M4 processor have three-stage pipeline design. So three-stage means for instruction fetch, decode and execution. Actually, the Cortex M3 and M4 processor are designed by ARM, and these processors are built on high-performance processor core, which is a 32-bit RISC processor with three-stage pipeline design, and it follows hardware bus architecture, which allows simultaneous instruction fetches and data access, and also the instruction set architecture in the Cortex M3 or M4 processor is called Thumb ISA. It will follow Thumb 2 technology, which is based on Thumb 2 technology. Actually, Thumb 2 technology supports a mixture of 16-bit and 32-bit instruction. Also, these processors have on-chip bus interface based on advanced microcontroller bus architecture technology, which allow pipelined bus operation for higher throughput. Coming into the memory system, it uses 32-bit addressing, which allows maximum 4 GB of memory space. The memory space is used by program code, data code, peripherals, and some of the debug support components inside the processor. And another important module is the interrupt controller, which is called nested vector interrupt controller. So this model is supporting up to 240 interrupt requests and from 8 to 256 interrupt priority level, and support for optional memory protection unit to provide memory protection features like programmable memory or access permission control, and also it will support for bit data access into specific memory region using the feature called bit band memory mapping. So these are the features of ARM Cortex M3 or M4 processor. So this is the block diagram of Cortex M3 or M4 processor. So this processor contain contain the core of the processor. So the highlighted portion is the core of the processor along with nested vector interrupt controller, system tick timer, and optionally we have floating point unit. Apart from these, the processor also contains some internal bus system, memory protection unit, and set of components to support debugging operations. So this model is the debugging subsystem model. And also this internal bus interconnect is needed to route transfers from processor and the debugger to various part of the design. And this is a very important model, that is nested vector interrupt controller, which is used to deliver industry leading interrupt performance, and it includes a non-maskable interrupt that can provide up to 256 interrupt priority level. So the tight integration of the processor core and NVIC provides fast execution of interrupt service routine and also at the same time reducing the interrupt latency. And coming into the memory system, the Cortex M4 don't have program memory, SRAM, and cache memory. So instead, they come up with a generic on-chip bus interface. So the microcontroller vendors can add their own memory system to their design. Typically, microcontroller vendors will need to add following to the memory system. One is the program memory, and other one is the data memory, that is SRAM and peripheral. So this system bus will be utilized for SRAM and peripheral, and bus I code and decode interface will be used for interfacing program memory. And next unit is the memory protection unit. It is an optional feature on the Cortex M4 processor. So microcontroller vendors can decide whether to include this unit or not. If an unit is NPU is included, the applications can divide the memory space into number of regions and define access permission for each of them. So this unit is mainly used to make memory regions read-only to prevent accidental erasure of data in SRAM or overwriting of instruction code.